So in this equation, it's solving. So I could put it over 1, but I really don't need to. There's nothing wrong with the 5, but I don't like that there's an a. So I'm going to multiply everything by a. A. And then I see over here there's an a, but I already multiplied it by a. So now I can just make things go bye-bye. 5 times a, 5a. A up top, a up bottom, gone. A top and bottom, gone. And now I just solve. Add 1. Oops, excuse me. And divide. And I'm good to go. 3/5 isn't extraneous, so I'm fine. Let's look at number 2. Number 2 looks a lot like the homework. So, I feel like for some of you this is a little bit difficult. So if you look here, and I'm going to put it kind of to the side, there's an n, here there's a 4 and an n, and here there's a 4n squared. I could technically go n squared, n squared, n squared. 4n, 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 4n squared, 4n squared, 4n squared. But that's too much. What I do know is I want them all to be the same. So this one already has 2 n's. So I know that if I give this one an n, this will also have 2 n's. And this already has 2 n's. Well, this one has a 4. So I need to give this one a 4. And that one already has a 4. Therefore, your LCD, and what you're multiplying by, is 4n squared. So I'm going to go 4n squared. 4n squared here, and 4n squared here. I think you can agree that's the more obvious one to make go away. If I have an n squared on top and an n squared on bottom, it's gone. 4 times 1, 4. If I have 2 n's on top and 1 n on bottom, I have 1 more on top, and the 4's are gone. 1 times n is n, and then minus 1, n equals 5. So just like in this problem, I can break this down. This is, let me do this to the side, an 8, an m, and an m. This is a 2, an m, and an m, which really means 8 is 2 and 4. And then here's 2 times 2 times m. So they all have a 2. They all have an m. But then this has an m and this has an m, so this needs an m. This should actually be 2 times 2. So this has a 2, this has a 2, so that needs a 2. Now they're good. And then one more 2. Now, some of you might just go, well, 8 is the biggest of 2 and 4, so 8 is the LCD. And some of you might also say, well, there's 2 m's, and that's the biggest as well. So I'm just going to go 8m squared, 8m squared, 8m squared. I feel like it's easier to cross off the 8m squared. The 8 and the 2 turns into 4, and then I have 2 m's on top, 2 m's on bottom, so those are all gone. 8 divided by 4 is 2, 2 m's on top, 1 on bottom, 1 more on top. Okay, now I'm going to write what's left. 1 equals 4 times 3 is 12 minus 10m. Negative 11 equals negative 10m. M equals 11 over 10, and I can tell none of them are extraneous. Okay, make sure you get that negative in there. So when I see a 4, an 8, and a 2, I know that I'm going to multiply all of them by 8. And then I see there's 2 p's for all of them, so that is my LCD. And now I can start crossing off. 8 over 4, 2. 2 on top, 2 on bottom, gone. 2 times 1, 2. 8 on top, 8 on bottom, gone. P squared on top, P squared on bottom, gone. All that I'm left with is P minus 8. 8 on top, 2 on bottom, 4. 2, 2, gone. 4 times 1 is 4. But remember, there's a negative. So 2 equals P minus 12. P equals 14. None of those are extraneous. I'm good to go. Okay. Let's look at the next one. These look crazy, but I know I can factor. So I'm going to do that right now. And now I will cross that off. Do my 3 sets. X plus 1, X plus 4. X plus 1, X plus 4. And when I do that, it eliminates that X plus 4 right there. So the great thing about this one is that all of this is gone. All of this is gone, and the X plus 4 is gone. That means I'm left with 3 plus X plus 2 equals. Now, the hard part is this. 6x plus 2, and x plus 1. I'll box it out. 6x squared plus 8x plus 2. Now I set it equal to 0. 3 plus 2 is 5. Set it equal to 0. And start doing my factoring, get my values, and check for extraneous solutions. So I realized I made a mistake. 2 minus 5 is negative 3. So I'm guessing there's a 3 and a 1. Let's see. Let's do 3x and 2x. So 2 and 9 gives me 7, positive, negative. I set those equal to 0. I get 1/3, not extraneous, and negative 3/2, not extraneous. So the first thing I'm going to do in number 6, change the signs of everything to the right. Next, I see there's a lot of factoring. So I'm going to take out an r. And then I'm going to factor some more. This is a crazy one for sure, but I definitely think this is the way to make sure you're good to go. Factor that. And that's already factored. Now I'm going to multiply. I'm going to give everything an r plus 3, and an r minus 1. I'm going to give everything an r plus 3, and an r minus 1. R plus 3, r minus 1. When you look, the r is already covered here, and the r plus 3 is covered over here. And if you look, the r plus 3 is covered here. So that means I'll be able to eliminate all my denominators. R plus 3, r minus 1. All the bottom is gone. I'm left with 1. I can eliminate the r. I can eliminate the r plus 3, and I'm left with r plus 1, or minus 1. So I have a negative r plus 3 times r minus 1, and then I'm going to box that out. And then I'll eliminate the r plus 3. 1 times r is r times r is r squared, minus r. Now, I set things equal to 0. So I notice that if I move this r squared over here, it's negative, and that makes me uncomfortable. So I'm actually going to simplify this a little bit too. So negative r squared plus 4r minus 2 equals r squared minus r. So I'm going to add r squared minus 4r, put a 1 there, plus 2. So I'll get 2r squared minus 5r plus 2, and go from there. Okay, you get the game. Let's look at number 8. I put this over 1. Well, I don't really need to, but it might help me with sanity. I just give a 3n to everything. So this is gone. This is gone. And then 1 times 3n is 3n. Subtract 1, subtract 3n. Oops, subtract 3n, subtract 1. Dot, dot, dot. This one. Before I do anything, I see that I could factor. So, I'm going to take my blue. Ooh, and I better change the signs. So I give everything an x, and an x. That takes care of this x. So I'm left with x plus 6. But the problem is, it doesn't take care of this x plus 1. So I have to make sure I give everything an x plus 1. So really now I'm going x plus 6 and box it with the x plus 1, which gives me x squared plus 7x plus 6 equals, and I have to do the 1 times the x plus 1, which is really x squared plus x. And then I eliminated the x plus 1 and I eliminated the x, so minus 1. The x squareds are gone. 6x equals negative 7. X equals negative 7 over 6. Honestly, what I really needed you to focus on was how to do the LCDs.